Okay, so here's the first problem we'll talk about on Delta Math. It says follow the guided instructions below to rotate the figure 270 degrees counterclockwise about the origin. So this kind of walks you through. This is the only way they do them in terms of just straight rotation problems. So again, you just kind of have to walk through the directions, and hopefully you get the problem correct. Watching this instruction will, I think, help. So it says draw a circle centered at the center of rotation such that one of the vertices of the figure is on the circle. So notice that the center of rotation is the origin. It's said right here. So that's where the yellow dot is. And I'm just going to drag it to the closest point. I'm going to click and drag to the closest point. And there, what I've done is I've made a circle. And this circle has a point on the circle that's also on the triangle. So now it says click and drag to draw a line through the yellow center and the vertex on the circle. So yellow line. Okay, so there I am. Now it actually goes through 2 points. That's just a coincidence, not necessarily going to happen to you. So now it says draw a line through the yellow center that is perpendicular to the line you just drew. Well, why in the world would they focus on perpendicular? Well, you're doing, right, this idea of perpendicular. You're doing a 270 counterclockwise. Remember that 270 counterclockwise is equal to 90 clockwise. So what they're doing here is they're using the fact that you're going to move in a right angle and do that here. So to do that, what I have to do is I have to look at the slope of this line. So the slope of this line goes up 1 and right 2. So that slope is up 1, right 2, 1/2. So then my line that's perpendicular has to have a slope that is an opposite reciprocal of that. That's -2/1. So down to right 1. So from this dot, I'm going to go down 2 and right 1. And there it is. And once you get it, it'll tell you, right? It'll lock it in like it did for me. And now it says, rotate the figure 270 degrees counterclockwise using the red dot. So each of the places where these lines cross a circle is an increment of 90. So we're going 270 counterclockwise. That's going to be three 90 degrees going this way. So watch what I do with my red dot. I'll go 1, that's 90, 2, 180, 3, 270. Good. And once I get there, it locks it in place and it says fill out all the corresponding points on the image figure. Now what I can do is I can animate this to show the rotation. Ooh, nifty. Okay. But now comes either you're looking at the figure or the rule, right? So initially I could have used the rule because when you do 270 counterclockwise, X and Y switch, and the second number becomes opposite. And again, I think of it as first to fourth quadrant kind of thought. But again, just memorize the rule. Or now we just have to look at the coordinates, right? So this is A prime. So what are the coordinates of? So that's an A is 4, 2. 6, 1 is here. That's B. This is going to be B prime. And then 8, 4 is C. And that'll make this C prime. And now we'll just kind of count the coordinates going left to right first, up and down second. So A prime is now 2, -4. Switch X and Y, second number is negative or opposite. Then we have 6, 1. So now we're going to go 1, -6. Switch X and Y, second number is negative, or opposite, I'm sorry. And then 8, 4 is now 4, -8. And there we go. Let's try those values. Oh yeah, we're correct. Green check mark. Cool. Okay. All right, let's do another one of these type of problems. All right, let's look at this one now. So now it says, again, follow the guided instructions. But now we're going to do 180 counterclockwise about the origin. So again, same thing. We're going to make that circle starting with the origin out to a point on my triangle. I'll go to the closest point. Now it says drag and draw a line through the yellow point, and that point you just drag to the circle. Okay, notice that no other point goes to that line, just like I told you. So now I have to draw a line perpendicular. So again, what's the slope of this line? Well, the slope of this line it looks like you have to go, now that's a close, but that's not exact. I think you have to go down 2 and right 5. So that's a slope of -2/5. So the slope of our line, which is perpendicular, has to be the opposite, positive, and the reciprocal 5/2. So I will count that from the origin. I will go up 5 and to the right 2. And once I get it, it'll move on, which it just did. Okay, so now it says rotate the figure 180 degrees counterclockwise. So that's going to be two 90-degree increments going counterclockwise. So you'll see I grab the red dot and I'm going to go 1 to that line, 2 to that line, and there I go. And now it says fill out all the corresponding image of the figure. So again, if you recall from our rules, and I think they're helpful to know, right, that if you're doing 180 rotation, so x and y stay put, but they both become opposite. Sorry. So I'll make that cleaner. I made the negative after the y for some reason. So they both become opposite. So opposite of x, opposite of y. Okay? So you can use that rule down here, or you can actually look up here. So -8, 2 is this one. -8, 2 is this point. It's going to be this point, which is now 8, -2. You see, the 8 and 2 stayed put, but they switched signs. So this one should be 5, -2. Let's see. 5, -2. Yep. Oh, I'm sorry. Yeah, 5, -2. And this one should be 6, -5. Let's see. 6, -5. There we go. Try those values out. We are correct. Boom, boom. Green, check mark. Awesome. All right, one more problem to show you. All right, so we'll do one of each of these. So these are just quick problems, right? These are rule problems. So it says, what is the image of the point -9, 1 after rotation 90 degrees counterclockwise about the origin? So again, this is our rule. So for 90 degrees, when you take x and y, the x and y switch, and the first number becomes opposite. So we're going to switch the 1 and the -9, and the first number becomes opposite. And there you go. And that should be -1, -9. Notice I did not touch the -9. I did not make it positive because it doesn't say make it positive. It just means keep it the same. Okay. There we go. All right, let's do one. We'll do one of each of these. Okay, here we go. Now we're doing a -7/5 after rotation 180 about the origin. So again, for 180 degrees, x, y, they stay the same, but they both become opposite. So 7 and 5 will stay the same, but the -7 becomes positive, and the +5 becomes negative. And there's your answer, 7, -5. There we go. All right, last one coming. Okay, the last one here, it says, what is the image of the point -7, -8 after a rotation of 270 counterclockwise about the origin? All right, 270. So x and y will become y and x, but now the second number becomes opposite. So y opposite of x. So the numbers will switch. The -8 comes forward and stays the same, but the -7 goes second and it becomes opposite. And the opposite of -7 is +7. So again, notice these signs don't match the y opposite of x because it's not a positive and a negative. It's a number stays the same, number becomes opposite idea. All right, so keep thinking in that way. Oh, yeah. Okay. So again, hopefully this gives you a good idea of what you're doing rotations. Now I am going to make another assignment. This other assignment is like a 9-1 through 9-3 rigid motions summary assignment. I will make a video or two involving some of those problems. But again, we're putting together translations, reflections, rotations all into these problems. Okay. All right. Thanks for watching.